All right, let's derive the derivatives for secant of x and the cosecant of x using the derivatives of the sine function and the cosine function. The derivative of the sine function is the cosine function. The derivative of the cosine function is opposite sine function. Okay, so let's find out what is the derivative of the secant. Well, first off, the secant can be written in terms of cosine. 1 over the cosine of x. Okay, now there is a what's called a reciprocal rule for derivatives. However, in my experience, going through the quotient rule is always beneficial. It reinforces some basic derivative facts, and I'll show what I mean by that. So I've got f prime of x, I've got low d high minus high d low all over the square of what's below. Again, that would be cosine x quantity squared there for that denominator. Okay, so we've got some operators here. So using the quotient rule, I have to take the derivative here of a constant. The derivative of a constant is 0. Had I used the reciprocals rule, I would not have talked about that here. So I've got cosine x times the derivative of 1, which is 0, minus the derivative of the cosine of x is opposite sine x. And that's all over the square of what's below, which is cosine squared x. Okay, so I've got cosine x times 0 in the numerator. That's going to be 0. Then I've got negative sine, so that's going to become a positive sine. So I've got sine x over cosine squared x. So I do have a form of the derivative for secant. However, I'm going to split it up and basically get rid of cosine in the denominator, and I'm going to make this 1 over cosine x times sine x over cosine x, which gives us the secant of x times the tangent of x. And it wouldn't be wrong if you said the tangent of x times the secant of x. They're trig functions. They represent real number values, so they would commute as such under the operation of multiplication. So secant x tangent x, or tangent x secant x. And what was that? That's the derivative of the secant function. So the derivative with respect to x of the secant is equal to the secant of x times the tangent of x. All right, well, let's look at cosecant of x. Cosecant of x is 1 over the sine of x. Okay, so similarly, let's use the product rule, or pardon me, the quotient rule to find its derivative. F prime of x. I've got low d high minus high d low all over the square of what's below. So again, that's going to end up being the sine squared of x. Okay, similarly here, we've got operators in that numerator. That tells the reader we've got calculus to do. So I've got the sine of x times the derivative of 1. 1 is a constant. The derivative of a constant is 0. Minus 1 times the derivative of the sine function. The derivative of the sine function is the cosine function. So it's going to be minus cosine x over sine squared x. Okay, so f prime of x is equal to sine x times 0, which is 0. It's going to be left with opposite cosine x in the numerator over sine squared x. Just like over here, I want to split it up. And I'm going to say f prime of x is equal to negative 1 over sine times cosine x over sine x which means that the derivative with respect to x of the cosecant of x is equal to opposite cosecant x cotangent x. Opposite cosecant x cotangent x. And just like the derivative for the secant of x, if I switch these two functions around, which we can do because multiplication commutes, those are real number values. Okay, we've got opposite cosecant x cotangent x. And again, it could be opposite cotangent x, cosecant x. That is the derivative of the cosecant of x. So we've added those to our repertoire of derivatives.